Until the condition is satisfied, we do the operations iteratively. That is the algorithm. After performing every one iteration, we will check this condition before moving on to the next iteration. By subtracting the present iteration from the previous iteration, if it is greater than this, we say that the root is not yet found. Once when the condition is satisfied, it stops executing and terminates at that point and gives you the root of an equation. Hello everyone, it is Dr. Ravi Kumar YB, Department of Computer Science, Vidhyaashram First Grade College, MYSURU, the Temple of Excellence. In today's session, you will learn about the bracketing methods. What is the meaning of bracketing methods? Let me take you into the details of it. That is, in case of bracketing method, which is one of the simplest and reliable iterative methods for the solution of nonlinear equations. I am talking about the nonlinear equations now, because earlier I was discussing about the linear set of equations, that is 2x plus 3y plus 4z, something like that, for solving the methods, for solving the problems using the methods of Gauss elimination, Gauss-Jordan method, and there is one more method called Gauss-Seidel. The Gauss-Seidel method is again works on the linear set of equations, but we are concentrating on non-linear set of equations now. So we have already solved the non-linear set of equations using the iterative methods like bisection method, then Newton-RAPHSON method, regular FALSI method, and secant method. Let us today revise all these four methods in one session. That is this. This method is also known as binary chopping. What is the meaning of binary chopping? We have divided the information or interval into two different parts. That is called as binary chopping, which you will come across in the bisection method, the interval method. Given the function f of x, which is a real and continuous in an interval a comma b, f of a and f of b are of opposite sign, that is f of a into f of b less than 0, then there is at least one real root, that is this. Between a and b we have one real root for this function f of x. The same thing is already explained, that is the algorithm like this: a naught equal to a and b naught equal to b. Some values are assigned to it. Until the condition is satisfied, we do the operations iteratively. That is the algorithm. So if that is the case, we have an algorithm like this: f of a n minus 1 plus b n minus 1 divided by 2. Then we say that zeta is equal to a n minus 1 plus b n minus 1 divided by 2. Then we have one more if condition, that is this, for finding the decisions. That is a n minus 1, that is f of a n minus 1 into f of a n minus 1 plus b n minus 1 divided by 2, which is less than 0. After performing every one iteration, we will check this condition before moving on to the next iteration. That is a n is equal to a n minus 1, bn is equal to a n minus 1 plus bn minus 1 divided by 2, because we have the value which is less than 0. Otherwise we say that a n is equal to this, that is this becomes, this set of equation becomes the value of a. If it is greater than 0, this becomes the value of a, that is a n is equal to a n minus 1 plus bn minus 1 divided by 2, and bn is equal to bn minus 1. As I have already discussed with you, that is, if the value of f of a into f of c is less than 0, what do? We will assign the value of c to b, else we will assign the value of c to a. This is the condition I am using this here, and if. So in this case, I am using the same properties here. If it is less than 0, I will assign the c to b, else I will assign the value of c to a. The same thing is followed here. Now the subscripts a0, b0, an minus 1, bn minus 1, an, bn, or maybe anything, an minus 2, bn minus 2, an minus 3, bn minus 3, or anything denotes that the iteration number. A0 indicates the first iteration, A1 indicates the second iteration, A2 indicates the third iteration, then we have AN-1 indicates the n-1th iteration, because I am starting from 0 here. AN indicates the n+1th iteration, wherein you will find the roots of an equation. So if that is the case, the 0th or starting iteration, that is AN, BN, is the interval for the nth iteration or n+1th iteration, I will call it as, because I am beginning from 0 here, 0th iteration. An iterative process must be terminated at some stage until satisfied. Refers to as the solution convergence criteria used for stopping the execution process. We must have an objective criteria for deciding whether to stop the process or not. We may use one of the following criteria depending on the behavior of the function, that is monotonous or step, variation, increasing or decreasing. Let me clarify this entire paragraph in a simple term, that is this. Convergence criteria. What is the meaning of convergence criteria? I have obtained the value of 2.306153942. This is the value of the present iteration. In the next iteration, I will get the value of C, which is equal to 2.3061549443. This is the value I have obtained in the next iteration. That is, this is in the x4th iteration. In the x5th iteration, that is 5th iteration, this is the value I have obtained. What is the relative error of this? I will subtract this from this or this from this. If I do that operation, what happens? That is 2.306154943 minus 2.306153942. If I subtract this, I will get some value which is equal to 0.000001001. This is the value I have obtained. But in this convergence criteria, what is that convergence criteria indicates? Error epsilon is equal to 0.001 is the criteria I am mentioning here. If there is a value which is less than this, we say that it is not yet convergent. That means the value which is less than this. So we say that the roots of an equation is found and it is convergent. Then I say that the root as found, the root is obtained. The root is obtained. That is, what is the root of an equation? That is 2.306154943 is the root of an equation. This is what I am going to state now. Because it is less than this value, relative error. If it is more than this error, if the value of this is more than this error, how do I get this value? By subtracting the present iteration from the previous iteration. If it is greater than this, we say that the root is not yet found. So if that is the case, I have to iteratively perform once again the operations of bisection method so that this process is repeated. This process is repeated. Terminating condition is obtained. Which is the terminating condition? Error. This is the terminating condition that defines where to stop executing the bisection method. Otherwise, it goes to the infinite loop. I do not want the program to enter into an infinite loop. I want to stop at some terminating condition. The terminating condition is specified by this epsilon. Relative error. That is the terminating condition or stopping condition of execution of a statement or a program. Now, let me take you into the different types of error here. Tolerable absolute error. My dear students, please make a note of it if you are watching this video, because it is very, very important in the examination. You will get 1-2 marks question from this, especially from this slide. What is the formula and what is define tolerable absolute error or just absolute error, or what is the meaning of relative error, what is the meaning of the difference in two consecutive iteration function values. You may get that value, you may get that questions in the examination. Absolutely, as per my knowledge, after going through previous year question papers, I have seen these kind of questions in 2 marks section. So please make a note of it and concentrate on it. That is, the absolute error is defined by this formula, that is xn plus 1 minus xn, that is present iteration minus previous iteration. What is the meaning of relative error? The relative error is defined by xa, or xr is the relative error, then xn plus 1 minus xn divided by xn plus 1 into 100%, which is already discussed. So what is the condition here? Less than epsilon, which is less than epsilon means what? Epsilon, relative error. So this is the function or the formula we are using to find out the relative error. Absolute, this is the criteria, that is present iteration minus previous iteration divided by present iteration, that gives me the relative error. Then which is the function used as xn? If f of xn plus 1 is less than the error, then we say that the value of xn tends to zeta. Then we have the difference in two consecutive iterations. If I am in 4th iteration, I will consider 5th iteration. That is, if I am in 5th iteration, I will consider 6th iteration. That means the difference between 6th and 5th is considered. The difference between 5th and 4th is considered. So that is called as a consecutive iterative values, that is obtained by f of xn minus 1 minus f of xn is taken as a modulus of this, that is the absolute value of that gives me the value of this, which is less than error rate. That is the two consecutive iteration function values that is defined by this. My dear student, let me move on to the next important slide. I think you are understanding very well for all these concepts. Please see to it here. Absolute error is almost equivalent to 10 to the power of minus 70 or 10 to the power of minus 12 or 10 to the power of minus 10. So we have all these things. For example, this is the example considered here, and this is an interval considered here, that is a and b. A is equal to 1, b is equal to 2. If that is the case, what is the value of a here? F of 1, it is 5.5, which is minus 5.5, which is negative sign, which is f of 2, which is 6 greater than 0. So it is a positive sign. So we have f of a into f of c. How can I obtain that? Negative into positive obviously leads to 0. If that is the case, I have to find out the value of c. That is, c is equal to a plus b divided by 2. What is the value of c then? 1 plus 2, that is 3. 3 by 2 is 1.5. I have to substitute this value into this equation. That is 2 into 1.5 whole cube minus 2.5 into 1.5 minus 5. That gives me some value. That is the value of f of c. Then I will cross verify what is the value of f of a into f of c. Then f of a star f of c leads to some negative value or some positive value. If it leads to some negative, negative into negative, that leads to positive. Negative into positive, that leads to a negative. Negative into negative leads to a positive value. If it is positive, then I will consider this condition. That is this condition. Yes, if it is negative, I will assign the value of c to b, else I will assign the value of c to a. This is the condition I am going to consider here. The same thing is explained here. So please observe this carefully here. A is equal to 1, b is equal to 2. Then we have this condition criteria here, 1.5, which leads to minus 2.0. Minus 2.0 into the minus 5.5. That gives me some minus into minus positive value. So if that is positive, I will assign the value of c. That is 1.5 to this a. Now, which is the next value of a then? A1 is equal to 1.5, b1 is equal to 2, the same thing that retains the same in the next iteration. So this process is repeated until the roots are found. So please observe that carefully here. This represents the iteration number. This represents the initial value A0, A1, A2, A3, A4, A5, so on up to A12 I have here. Similarly, B0, B1, B2, B3, B4, B5, so on up to B12. Then we have C. What is the value of C? C is equal to A plus B by 2. That is C1, C2, C3, C4, C5, C6, C7, C8, C9, C10, C11, C12. We have 12 values. What is this condition indicates? F of, this is C. This is F of C. That is this. This is again a negative value, F of C, F of C2, F of C3, F of C4, F of C5, so on up to F of C12 I have. Then what is to be considered? Which is the decision criteria? F of A into, this is AN. I will take the F of AN. What is this F of AN? What is this F of C? Then I will consider the multiplication of F of A into F of C that leads to the decision maker. That makes the decision of which value is to be considered in the next iteration. By following this procedure, I will be left with some value, that is this 1.660100939. That is the value, that is the roots of an equation is. The root of an equation is this one. This is the root of an equation. If you observe this carefully, you are seeing that 1.6600, there is a difference in this point. That is epsilon equal to 0.000. Here you will observe the difference 1, which is, what is the condition mentioned here? Epsilon is 0.001, which is less than this. This is less than this value, so that it terminates the iteration. This is the stopping criteria. This is the stopping criteria. It checks whether the value of the present iteration with the previous iteration is less than this criteria, stopping criteria. If so, it stops executing this condition, that is iterating over the set of statements to find the roots of an equation is stopped. That is the way we are going to follow. So similarly, we have one more function, that is sine square x minus 8 cos to the power of 5x equal to 0 in the interval 0.5 and 1.5. My dear students, of course, I know I am stating all these things with a slide, but the thing is, you have to solve all these questions within 5 to 6 minutes, or sometimes a maximum of 7 to 8 minutes. You cannot take more than that time to solve any bisection method. But obviously, if you follow the regular approach, you require minimum of 15 to 20 minutes. Then how can you solve this question in the examination in a span of 7 to 8 minutes? Obviously, it is not possible. It is very difficult. So, in the next session, or in my next 2 sessions, after 2 sessions, I will show you the shortcut methods, wherein how the calculators can be used to store the equations, and you have to just pass on the values so that you will get the roots of an equation very easily, and you can find the roots of an equation within 5 to 6 minutes. That is possible through that shortcut methods. And if you write down in the tabular representation, that is sufficient enough to secure the complete marks assigned to that question. I will make you that. I will make you that. Please follow this. The second question, 5 sine square x minus 8 cos to the power of 5x equal to 0 between the interval 0.5 and 1.5. So these are the interval values we have obtained here. A, B, C, f of C, then f of A, then f of B, then this f of A with f of C is multiplied to get the decision making. That is this. After this, we have found the roots of an equation is this. What is the root of an equation is this. Present iteration minus previous iteration gives you the value of 0.000, some value, again 0, 0, 2, some value, which is less than 0.001. This is the terminating condition. What is the value which is less than this? So I will call this as the terminating condition as found, and the roots of an equation is obtained. So that is the root of an equation. So please we make a note of all these kind of transcendental equation. We have this kind of equation, that is 2x cos 2x minus of x plus 1 whole square, that is this is whole square. Then we have x into cos x minus 2x square plus 3x minus 1 equal to 0. This is a polynomial kind of equation. This is a trigonometric kind of equation. Again, it is a transcendental equation. So we have to solve these kind of transcendental equations more in number. So the same thing is explained in description here. The only utilization of the function f of x is in checking the whether f of a into f of bn is less than 0. That is the condition for deciding which value is to be used, whether to use the value of c to b or c to a, going to be decided by this condition. So the value an comma bn as a bisection method, but also in calculating the end points an comma bn, the new interval, the same thing is explained here. We have an minus 1 and bn minus 1, which shall be described like this. So we have next regula falsi method, or by the method of false position. The false position again follows the same condition, that is f of a into f of b is greater than 0 or less than 0. If that is the case, we shall move on to this condition. What is the formula I am going to use? A into f of b minus b into f of a divided by f of b minus f of a. If that is the case, what is the formula? A into f of b minus b into f of a divided by f of b minus f of a. This is the formula we use to find out the value of x1, x2, x3, x4, so on up to xn, nth iteration. By doing all these calculations, we will be found with these values of this iteration. Please observe this. We have an equation called 2x cube minus 2.5x minus 5. What is the interval I am considering here? 1 and 2 are the intervals. So f of 1 and f of 2 is calculated, which is minus 33 less than 0. And then we have a0 is equal to 1, b0 is equal to 2. That is the first iteration. Then what is the value of f of 1? F of 1, then 1 is to be substituted into it. 2 into 1 cube minus 2.5 into 1 minus 5 is equal to 0. I'll get some value, and that is considered as f of a. What is f of a? Or f of 1. Then what is b? B is equal to 2. B is equal to 2. If that is the case, f of 2 is equal to some value. Then f of a into f of a into f of b, that is a into f of b minus b into f of a divided by f of a, f of b minus f of a. That is the formula which I discussed earlier. This is followed here to get this equation. Please observe this carefully. You will get the roots of an equation even earlier than the number of iterations which you have observed in the bisection method. In this case, f of b into a minus f of a into b divided by f of b minus f of a. After doing this calculation, we have obtained this value. So this is the value of this. If I take the function of this value, I'll get this term, which is very, very important. Which is very, very important. I will check for the next iteration. What is that value? Minus 5.5 and minus thing. Minus into minus, it becomes plus, which is greater than 0. If that is greater than 0, what has to be considered? The value of c. That is, this must be considered as, this must be considered into the value of a. If that is the case, what happens? Please observe this carefully now. We have the value 1 and 2 are the intervals, 1.47. What is the value of that by f of c? This is the value. If it is negative, this becomes the value of b. If it is negative, yes, f of a into f of c. What is f of a here? F of a is negative, already negative. F of b is also negative, that is negative. F of c is negative. So multiplication of this negative into negative, that leads to a positive value. That is f of a is some value you will get, that is a negative value is obtained, and f of c is what? A negative value, negative into negative, that becomes a positive value. If it is positive or greater than 0, this becomes the value of this a. If it is negative, in this case again it is negative, what is the value of this f of a? The value of f of a is also a negative. So negative into negative, that becomes positive. If it is positive, this becomes the value of a. If it is negative and this is also a negative value, this becomes the value of a. So this process is repeated until the roots are obtained. So the convergent is faster. How many iterations have been taken? 8 iterations have been taken for finding the roots of an equation. If you look at this, we have 0.000002, something like this. Suppose if the terminating condition mentioned as 0.001, then obviously this is less than this value. So if that is the case, we have terminated the iterating of these set of statements, because we have found the roots of an equation, that is this. Roots of an equation is this. Next, the same thing is explained here in terms of this, that is the formula, weighted average, that is a into f of b minus b into f of a, that divided by f of b minus f of a, that is for finding the regular FALSI method roots. And also the convergent is faster. It converges faster than the bisection method. That is the thing you need to observe here. We have found that an and f of an as a pair of values, bn and f of bn as a point of intersection, where exactly the curve crosses the x-axis. This is called as f of a. Obviously, I will draw some line. This is called as a, and this is called as f of b, and the point of intersection, this is called as b. Next, again, I will find one more value. This is called as f of a2. And I will call this as a2, and if I find some value, that is f of b2, I will call this as b2, and I will drop a normal. This becomes b2, that is b0, b1, b2, so until I reach this condition, that is at this point of iteration, this point of juncture. This is called as root of an equation. What is that root mentioned here? 1.6600997448. That is the value I am getting. So if I consider that this as my 1 and this as my 2, this is considered as 1.660 0999744 0997448. This is the point of juncture that is going to determine the roots of an equation. So this is how we are going to find out that. Next, yes, if you look at this diagram, you will clearly observe that this is the point of juncture where you will see the roots of an equation. For this equation, 5 sine square x minus 8 cos to the power of 5x equal to 0. That means f of x equal to this. This is the criteria we have given here. How can I find out the roots of an equation? By considering the interval 0.5 and 1.5 as the interval. After this 6th iteration, I have found the roots of an equation, that is 0.7013679147. If I subtract this from this, what happens? 0.7013689280. If that is the case, 0.000001, something like this, which is less than 0.001, that is epsilon. Usually in the practical examinations, you will be asked to increase this value. If that is the case, 0.001, again the number of iterations are increased. Then again this value is less than this value, so the terminating condition is obtained. Suppose if they ask you to increase this, again you have to increase this. Then again 1, 2, after decimal point 1, 2, 3, 4, 1, 2, 3, 4, again it is less than this. The number of iteration increases. So this is how the terminating condition is set to determine the roots of an equation. So we have one more equation for solving x log x to the base 10 minus 1.2 equal to 0. My dear student, please consider these example questions as an assignment. Please solve these questions in your home so that it increases the speed of finding the roots of an equation in your home. And of course, once you get the shortcut methods, definitely there will not be a problem. But anyhow, let us try to solve these problems and make use of these calculators handy so that you can do the calculations very quickly. Even when I explain you about the shortcut methods, you will find it easy to use the calculators. That is the reason I am giving you these assignments. Kindly take this as an assignment and solve it at home once again. Use these values and keep it separately and do workout on the assignment questions. We have the Newton-Raphson method. For Newton-Raphson method, which is that equation considered here, x minus 2 whole square. See here, unlike the earlier methods, the method requires only one appropriate starting point, that is the initial values or initial guess of the root of the function f of x equal to 0. At x0 comma f of x0, a tangent to f of x equal to 0 is drawn. Equation of this tangent is given by y is equal to f dash of x0 minus x0 plus f of x0. So if that is the case, this is the formula I am using here. How can I write down that? Xn plus 1 is equal to xn minus f of xn divided by f dash of xn. This is the formula I am using. If n equal to 0, this becomes x1 equal to x0 minus f of x0 divided by f dash of x0. So this is the formula I am using for finding the values during the first iteration. What about the second iteration? x2 equal to x1 minus f of x1 divided by f dash of x1. So this becomes the formula for finding the values during the second iteration. This is during the first iteration. This is during the second iteration. So similarly for third iteration, fourth iteration, so on and so forth until you meet the criteria which is epsilon, that is absolute error. The condition is satisfied. Once when the condition is satisfied, it stops executing and terminates at that point and gives you the root of an equation. So if you observe this again, you will see that the tangent is drawn at one point. Please observe this carefully. The Newton-Raphson method is also called as a tangent method, a secant method, as the name indicates, tan and secant. So the secant crosses the curve at 2 points, so that is called as the secant method. But this is a tangent method or Newton-Raphson method. So it crosses or touches the curve at only 1 point of juncture, so we call this as tangent method, which is the other name for regular FALSI method. See here, we have continuously the differentiable function f of x is and an initial value. What is the meaning of approximation x0, which is considered here? That is, this is the initial guess, that is x0. For x1, for x2, it is x1. For x3, it is x2. So we are going to get, how do I get this x1? From this, I will get the x1 in the next iteration. How do I get x1 in this from the previous iteration? How do I get x2 from the previous iteration? How do I get x0? I do not know. I have to guess some initial value. So that is why it is called as initial guess is needed. Observe this carefully here. Xn plus 1 is equal to xn minus f of xn divided by f dash of xn. That is the formula we are using here. So the same thing is explained in terms of explanation. That is f of xn into xn minus 1 minus f of xn minus 1 into xn divided by f dash of xn minus f of xn minus 1. That is f of xn minus 1, that is this value which is considered here. And add and subtract f of xn with xn. Then you will get the value of xn plus 1. That is the one we are getting this. The same term f of xn into xn minus 1 earlier, it has become xn now. Now, what is f of xn minus 1, which is equal to xn minus 1, xn minus xn minus 1. The xn is same as it is here. We are further simplifying this. F of xn minus f of xn minus 1. Earlier it was f dash of xn. Now it has become f of xn. Now after this we will get the value of this, that is xn plus 1 equal to xn minus f of xn divided by f of xn minus f of xn minus 1 divided by xn minus 1. If I further simplify this, what happens clearly? You will get this formula, that is this xn plus 1 equal to xn minus f of xn divided by f dash of xn. So that clearly indicates that as to how you can find out the formula. Right. See here, this is the equation given here. We have already used this equation. 2x cube minus 2.5x minus 5 is equal to 0. The root lies between the interval 1 and 2. By using the Newton-RAPHSON method, in this case we have this function 2x cube minus 2.5x minus 5. Here, after finding the first derivative, that is f dash of x equal to 2 into 3 x square, that becomes 6x square minus 2.5. Because the first derivative, that is f dash of x, what is x0? x0 is equal to 2 and epsilon equal to 0. So f of x0 is equal to 6, f dash of x0 is equal to some value, that is 29.5. If I substitute this value, that is x equal to 2, 2 square is 4, 4 into 6, 24, 24 minus 2.5, that gives this value, f dash of x0. Then we have this formula, that is x1 equal to x0 minus this. We will get this value, that is 1.709302187. But I have to make the decision. How can I find out the value of x2 now? How can I find out the value of x3, x4 based upon the decision, which shall be shown to you in the tabular form. Now see here. This is the value of, this is x1, this is x0. What about this? This is x2. What is the value I have obtained initially? 1.72. What is that f of xn? If f of x0, what is f of x1 and what is f of x2? I have to find out all these values. This has become the value of this when the value of this and this is positive. What is this? This is again positive value, which is a positive value. What is the f of this function? So that leads to some value which is again a positive. So I am getting the value of this into this. So after repeating all these iterations, I will be left with the roots of an equation, that is this. If I take the error rate, that is 0.000004, something like this, which is less than 0.001, which is the standard condition we consider here in the programs, practical programs. So again, I am considering one more equation, the same set of equations. That is, after solving this, you will get the iterative values, that is this. This is x0, f of x0. What is f of x0? What is this? F of x1. Then what is f of x2? That is this. These two are multiplied to get the value for the decision making process. So after 2 iteration or 3 iteration, I have found the roots of an equation, that is this. So we are going to use these kind of formulas to find out to solve the problems of Newton-RAPHSON method. So the same thing, that is the expansion of those things, which is not in your syllabus. However, I am giving you the explanation of all these expansion as to how you can derive the formula of Newton-RAPHSON method is explained here. Convergence factor, as I have already discussed with you, that is 2x to the power of 34 plus 4x square minus plus x minus 8. This is the equation given here. And if I take up this equation as g of x, I will rearrange this so that it turns out to be the value which is equal to this value. That is 8 minus x minus 4x square divided by 2 whole raised to the power of 1 by 3.4. This is the function, that is f of x equal to this. Now we use the iteration method, that is between the intervals, how we are going to solve that function. So many important practical problems, that is the linear set of equations, are explained here. Now we are moving on to the linear set of equations now. that is to direct approximation method. Let me not concentrate on this theory now, because let me take you into the practical approaches that includes the problems, because that is very, very important in this subject. See here, Gauss elimination method. Let me take you into the problems, example problems. Jacobi method, stationary iterative methods. Then we have Gauss-Seidel method. So all these are certainly important. Now we shall see the example programs here. Example questions. Example questions. My dear student, please make a note of it. All these things. Iterative method for solution. So these are the example programs for finding the roots or finding the values of unknowns of linear equations. In the next session, I will take you to the details of the Gauss-Seidel method. How you can find the values of unknowns. That is going to be explained in the next session. Kindly watch this video and practice few of the examples mentioned here in your own and compare that with the tabular representations, so that you will clearly become familiar with the concept of the iterative methods like bisection method, Newton-Raphson method, REGULA FALSI method, as well as secant method. Once after solving the non-linear set of equations, move on to the linear set of equations, that is Gauss elimination method, Gauss-Jordan method. By that time, I will be explaining you about the Gauss-Seidel method, again which works on the linear set of equations. Thank you very much. Thank you one and all.